Today we're looking at magnitude, direction and components of vectors. So I'll start with the magnitude. Okay, the magnitude is simply the size of the vector. Alright, so it's the size of the vector, how long it is, whatever way you want to look at it. The way we write it is put those signs there, which mean absolute value signs, which means the magnitude. So, tell me how big it is. Sometimes you just see the A without the thing. Direction. Use trigonometry. And it's measured, it's an angle obviously. From the direction of the positive x-action. Alright. Okay, so we better have a look at an example. So we've got to find the magnitude and direction of the vector 3, -2. Alright, so we might want to do a bit of a quick sketch as to what that looks like. 3, -2, so it's 3 in the y direction, -2 in there. So there it is, goes there like so. Alright, so if we create a right angle triangle there, then our magnitude, and so let's call that, let's say that that's A, vector A. Then our magnitude of A, we can get using Pythagoras, A squared plus B squared equals C squared. And when we rearrange that, vector A, of course, the magnitude of it is our hypotenuse. And so 3 squared plus -2 squared. So 9 plus 4. So square root 13. Alright, the other thing that we're after is the angle, and that's this bit in here that we're after. That's with the positive x-axis, of course. So our angle, again, if we look at that angle there, theta, we could say that theta relates to tan, which is our opposite over our adjacent, and our opposite is -2 and our adjacent is 3. And so what we end up with is -33.7 degrees. So remembering we're measuring in relation to the positive x-axis, so that's going in the clockwise direction, so that's a negative angle. Okay, so there's that. So there's our, if you like, our magnitude of vector A we can get from the square root of x squared plus y squared, and our angle we can get from our inverse tan of y on x. Alright, so those things will be helpful. Right, components. Okay, so if we've got a vector here, f like this, we can break it and we can say there's a whole stack of vectors. There's two of them. Here's another two, like so. And I could draw all sorts of combinations of vectors that add up to give them, give that one f. There are two of them, however, that are helpful. Call this one vector h, and then this one here, call that one vector v for it. And what's useful about those is that they form a right angle there. So the horizontal and the vertical components, that's where h and v come, are useful to us. So vector f is the horizontal component plus the vertical component. Alright, so of all the different components that could be made up to make a vector, the horizontal and the vertical ones are by far the most useful to us. Alright, so let's do some questions with those. Okay, so here's that example. Write the horizontal and vertical components of the vector with magnitude 5 and direction 120. So if we do a quick little bit of a sketch there, the angle's 120, positive x-axis, that's that there. And there it is out there, its magnitude is 5. Alright, so we've got horizontal and vertical components. So the horizontal component's there, and our vertical component is this one here. Of course, they make a right angle in there. Alright, so if that angle is 120, then this little angle in here is going to be 60 degrees, of course. Alright, so let's look at our horizontal component. So our horizontal component, which is our blue one, is equal to 5 cos 60, and 5 cos 60 is 2.5. Our vertical component, I forgot something about my horizontal component. It's pointing in the negative direction, isn't it? So I should say negative 2.5. My vertical component is 5 sine 60, which comes out to 5 root 3 on 2 in exact form. And that one is pointing in the positive direction, so we don't need to put a negative in that like we did in the horizontal one to indicate that. Alrighty, here's another fairly typical example. The car travels 12 kilometres in the direction of north 30 degrees east, so there's a vector for us. How far north and east of its starting position would it be? So we do a quick sketch on that. So there's north, south, east and west, like so. So 12 kilometres north, 30 degrees to the east. So this angle here is 30. We want horizontal and the vertical, or the northerly and the easterly components. So here's our northerly component, and here's our easterly component. Of course, they make a right angle. So for part A in the north one, the northerly component using trigonometry, it's just 12 cos 30. Okay, and then you get that 10.4 kilometres. And the easterly component, it's 12 sine 30, and that's 6 kilometres. It's gone in that direction. Alright, so that's it, there's our components. Alright, so that is what you need for exercise 13C, set number 3 on the question list.